Yes, good evening, guys. So, good evening, one and all present here. So, hope my voice is audible to everyone. Is it audible, guys? Yes, thank you all, guys. So, have you started your assignments? I hope every one of you sorted out with your groups and you have started with your assignments. So, you have left with only 9 days, guys. Exactly 18th. So, we are going to close the assignment submission. Why I'm not getting any responses? Hmm? Okay, guys. Yeah, good evening once again. I hope everyone is doing great today. So let's begin our contact session 14 on Spark, that is part 2 of Big Data System. Yeah, meanwhile, so can you all confirm once, guys? So can you all hear me clearly and see my screen? So can you type visible once it is visible? Why I'm not getting responses? Okay, thank you. Excellent, guys. So today we are going to uh, learn deeper into Apache Spark. So we all know, right? See, that is one of the most powerful engine for distributed data processing. And we will explore how to get started with the Spark and how to write your own programs and how to Spark runs in cluster environment. Okay, so before we start, guys, let's warm up with a small scenario. Uh, this is very, very important scenario for you people. Suppose you are analyzing millions of online transactions daily. If you run a Python script on your laptop, it takes 10 hours. Correct, no? So how can you make it run in 10 minutes? Any guesses? Any guesses, guys? Okay, so directly is saying Spark. Okay. Any other answers? Only Tanya is responding. What about others? I have Ravi Kumar, I have Azim, Jyoti, I have Varaprasad. Why no one is responding? MapReduce, run in parallel. Very good. Excellent answers, guys. By using parallel computing, by using Spark, by using Hadoop, by using MapReduce, we can achieve that, right? Yes, exactly. Your answer is perfectly correct, guys. So that's where Spark step in. Okay, it distributes computations across multiple nodes and keeping data in memory for high speed analytics. Okay, so let's see how to get started. Okay, so yes, guys, let me share my screen. Uh, Meanwhile, I'll do one thing. So even I will switch on my mobile. Yeah. See, last class we have stopped here, right? So I'm starting from the same place, guys. 1 second, guys. Give me 2 minutes. Okay. Yes, guys. So this is the topics for today's session. So first, I have to complete the previous session concept, and then I will jump to next part. Guys, look at the topics listed here. So these are our guiding agenda items for this session. So first we will start with introduction part, and then we will jump to getting started. Under getting started, so we are going to learn how to set up the Python environment, and we will solve some sample programs. Guys, by the end of this session, we will know how to install Spark and how to run it in both standalone and also cluster modes and build simple RDD based programs. So, all right, guys, let's dive in. Okay, so let us start with the very first slide. Guys, Spark supports multiple languages. I think everyone will agree with my point. Guys, it will support for Python, it will support for Java, and also it is going to support for Scala. Remember that Spark itself is written in Scala, guys, and runs on the JVM. Okay, so you can run Spark in local mode when experimenting on your laptop. Or you can run the same on cluster mode when processing large data sets on distributed system. My dear students, it runs seamlessly on Windows, Linux, and Mac operating system. Understanding, guys? See, I want you to note to run Spark locally. So you simply need Java 8 on your system. That is very, very important. The very first requirement is Java 8. Either set the Java home. See, either set the Java home environment or you have what Java in your system path. So anything is okay. So that environmental setting is very, very important one. And Python 2.7 plus or 3.4 plus and Scala 2. Where is mentioned? Yeah, Scala version is required 2.12 and R 3.1 plus. See, these are all compatible versions for the Spark actually. So check your runtime versions before running Spark programming. Okay, so this is what you have to check before checking, or you can call it as prerequisite also, guys. Okay, guys, now let's talk about the installation process. Guys, to start with the Spark, you will need to download and unpack the Spark tarball. Okay, this is very, very important. So directly you can download the Spark from the given website, guys. So this is the step I have given here. So first go to the Spark homepage. So that is http spark.apache.org download.html. You go to this link directly and choose the desired Spark release. So here I've given the steps. Choose the desired Spark release and package type. See, for example, Spark 3. Yeah, here Spark 3.0.0 preview to bin Hadoop 2.7.tgz. So this is the second step you have to follow. And third step, after downloading, always verify the release signature. Not only release signature, guys. Along with that, you have to verify checksums and project release keys. Guys, verification ensures integrity. So the package you install is not corrupted or tempered with. That is the reason why you have to go for this verification. So I think this is clear to everyone. So now look at here, guys. Look at here, everyone. So once the download is complete, open your downloads folder. You should see .trz file. Okay, so it is nothing but what is the trz file, guys? So here I have told you, right? That is tarball file actually. Okay, trz is nothing but tarball of your Spark file actually. So it is in compressed format. So on Linux or Mac OS, open the terminal. On Windows platform, use the PowerShell with 7-zip support. You can use whatever you want, guys, but you have to unzip it first. So suppose you are using Unix or Mac OS platforms. So then you have to use the command, guys. What command you have to use? Can anyone tell me what command we have to use to unzip this? Any answer? You're all familiar with that, right? Tar space minus XYZ space. You have to mention the version, is it? Spark hyphen 3.0.0. I'm taking the same thing. 3.0.0 power 2. Okay, let me write completely. Sorry, not power 2, preview 2. Preview 2 hyphen bin hyphen Hadoop 2.7 dot tgz. So this is the command you are going to use to extract your file. So this will create a new directory with the same name as the tarball. Okay, change it into directory using cd command, guys. By using cd command, you can change it into directory and list its content with ls minus l. ls minus l will list you all the content of that particular folder. So that's how you unpack Spark locally. I hope everyone understood this. Okay. So next, look at here, guys. Next is, what is the next one? Where I'm getting messages. I am not able to see here, guys. Let me check any messages are there in chat box. No, right? Okay. Thank you all, guys. Okay. Next, look at here, everyone. So now look at this slide, guys. So it highlights what happens after unpacking. So this is done, right? This is done, right? All these things I've told you already. So what you can see after what unpacking, you will see all folders like bin. You are going to see bin folder. Not only bin, guys, you are going to see sbin. Okay, look at here. You can observe here. Bin folder, and you can see sbin folder, configuration folders, conf. Somewhere we have conf. Yeah, here we have conf folder and examples. So here you will be having so many inbuilt examples. So you can use this example to run your code. Okay. So at initial part, and you have Python. Okay, look at here. You have Python. You have data folder. Okay, where do you have data? So data you have here. So guys, these contain executable and sample scripts. The bin folder, see this bin folder, I'm talking about this bin folder. So bin folder includes the Spark shell and submission script. And remember guys, this unpacked directory acts as your Spark home. That you should remember. Spark underscore home. So you can add it into path for easier access. Clear? And now I'm jumping into next slide. Now you can observe here. My dear students, Spark provides interactive shell. So just like R, or just like your Python interpreters, you can launch Python. See, for Python, you can use bin slash PySpark. Or for Scala, suppose you are using Scala means then what you have to do, guys? So you have to type bin slash Spark hyphen shell. That's it. So this is to what? Launch PySpark, and this is to launch Scala. Try to remember this. So these shells allow real-time interactions with distributed data residing in memory are on disk across multiple machines. Okay, look at this point, guys. So look at this point. The shell is extremely useful for experimentations, debugging, okay, and quick analysis before writing full applications. So yes, here both the points are mentioned. Correct? No? I hope everyone are getting. And you have to see this symbol. So this will show you the version of your Spark. Okay. Next, look at here, guys. So how to execute this shell? Guys, in Spark, all computations are expressed on collections that are distributed across the clusters. Okay, so these distributed collections are called as RDD, or resilient distributed data set. Okay, so this is the backbone of Spark, guys. So this is backbone of Spark. Remember this. So let's consider a simple example. So you create an RDD from local text file. So here I have mentioned the very first point. Then what you have to do? So the very first line you have to write here is val data equal to, you have to mention, see this, so here also we have done the same thing. So sc dot text file, right? You are opening text file. You write text file here. So with capital F, and inside this, you pass the file name. See, suppose you are using input.txt means, so write input.txt. So in this example, we have used readme.md. Correct? No, you can use whatever you want, guys, but you have to mention file name inside double quote. Okay, then perform simple transformations and actions such as, see here I've taken lines.count. So here I can take data.count, or you can use data.filter. So we have so many operations, guys. So you can use whatever you want. Once done, exit the shell using Control D. Okay, finally, everything is done means then exit the shell using Control plus T. Okay, now can anyone answer, guys? Can anyone answer? I'm going to ask you one question to you all. So can anyone tell me why RDD are called resilient? I think last class I have explained you, right? Why RDDs are called as resilient? What is your answer? So we cannot change our scalable and high performance. No, guys. Guys, because they can be rebuilt if a partition fails. Correct? No. So because of that reason, I'm calling it as resilient. See, last class I have explained you this, guys. I don't know why you people are giving wrong answers. Okay. So I hope now you all understood, right? So they can be what rebuilt if a partition fails. So because of that reason, so we are going to call it as resilience. Okay. Okay, no problem, guys. That's why before coming to what next class, you have to go through recordings, guys. So that is my sincere request. Okay, this is the summary. So let's pass for a quick recap. So we discussed how to install Spark, use interactive shells, and create RDDs for distributed data analysis. And the key takeaway here is Spark is in memory and fast. That already we have discussed. And RDDs are acts as, see, RDDs are its fundamental data structure, and it is a general purpose big data computing framework. See, for further reading, you refer this textbook, guys, Learning Spark. Okay, so you refer to this fantabulous book. So this is written by Karo and also Konvinsky, and official Spark documentation. You can go to website. In a website, you will be getting official documentations on Apache Spark. So that also okay for you people. Okay. So now see, this is the next session, that is Spark part 2. Guys, so now we enter the section 14, that is part 2. So where we focus on RDD application. So here I have mentioned one system design problem, guys. I am not going to explain this. So here I have given each and every options. So system design exercises I have given here. So I'm giving you this as a homework problem. So you go and solve this. And solution also given here. Okay, you can use all these solutions and you can work with it. So this is about 13th session concept. And now I'm jumping directly into 14th session concept. Okay. So now we are entering into Spark part 2, guys. So here, as I told, we are focusing on RDD operations, and we are focusing on standalone applications and cluster architectures. So these are critical concepts for writing and deploying real Spark applications. Now let's start with the heart of Spark, guys. What is the heart of Spark? So heart of Spark is nothing but RDD operation. One second, guys. Why, what happened? Why it is not enabled pen? One second, guys. Why I'm not getting pen here? One second, guys. Let me reshare. Yeah. Why I'm not getting pen? Okay, then I'll do one thing. I will use laser points. Okay. Yes. So what we are discussing here, guys. So as I told, we are started discussing about RDD operations. So we are discussing about RDD operations here. Okay. So guys, see, I'm starting with types of operations initially. Guys, every Spark RDD operations falls into two categories. So one is called as transformations and second one is called as actions. Okay, then what do you mean by transformations? Listen to me carefully now. Transformations create new RDD from existing one. Understanding my point, guys? So I want pen, guys. Otherwise, I can't. So let me do one thing. Let me check once what happened. What happened to this? See, for this, it is working. Why for this slide it is not working? One second, guys. Give me 1 minute of time. Yeah. Yes, guys. Thank you. So now, guys, as I told, so transformations create new RDD from the existing one. See, for example, you can use map function or you can use filter functions to create a new RDD by using existing one. Guys, one more very, very important point is they are lazy. So why it is called as lazy? The meaning of this is nothing actually execute until an action is called. So it is completely dependent on action. So Spark builds a linear graph of transformation instead of executing immediately. And what do we have on the other hand? The other hand, we have actions, right? See, actions on the other hand actually trigger computations. So they return values to the driver or so write result to the storage. Okay, guys, you ask, why do you think Spark use lazy evaluation? Okay, so what is the answer for that, guys? Yeah, before I'm going to ask to the system, what is your answer? What is your opinion on that? Hmm? So why do you think Spark uses lazy evaluation? Can anyone answer? Because to optimize execution plans and avoid unnecessary computations. Correct? No? Am I right or wrong, guys? It optimizes the performance by executing only what is needed. So because of that reason, so Spark uses lazy evaluation. Okay. And next, I'm moving forward. So now I'm talking about transformations. See, under transformations, I'm comparing two things, guys. So one is narrow, another one is wide. So here, right side, we have taken the diagrammatic representation for both narrow transformation and also wide transformation. Guys, transformations can be of two types, guys. So one is called as narrow and second one is called as wide. Okay, so narrow transformations means what? Guys, all data required to compute a partitions is in the same partitions of the parent RDD. Okay, the meaning of this is no data shuffling across nodes. No data shuffling across nodes, guys. So example for this is you are going to use map, filter, everything. And what about wide transformations? Guys, in the case of wide transformation, data from multiple partitions of the parent RDD is required. So in this case, Spark has to shuffle data across nodes to group or aggregate. So the best example for this is, so group by key, or you can take reduce by key. So these are the two best examples for this. So for this, so we have map and also filter. For narrow transformations, we have map and filter function. For wide, so we have group by key and also reduce by key operations. Guys, look at this classification. So it matters for performance tuning because wide transformations are costlier due to data shuffling. Okay, so here we have taken the example. You just look at the example taken here. See, Spark provides many transformations, guys. So we have highlighted only few. So first I have taken map of map function. Guys, map applies functions f. See what we are applying here. We are applying function f to each element and returns one result per unit. And next to that, we have flat map of f. So this is very much similar to your map function, but so it returns list of items per element. Okay. And what is the third one? Third one is filter of P. So this keeps only element satisfying predicate P. That is predicate P we have passed here. And next we have union. And next to that we have intersection. I have not mentioned. Yeah. So we have intersection. And one more we have distinct. So I'm taking all three union, intersection, and distinct, guys. So these are all standard set operations. Okay. And next to that, I already have told you about group by key, reduce by key, right? So what is group by key? Guys, group by key groups the values by key and shuffles data across the partition. What do you mean by reduce by key? What is the function of reduce by key? Guys, it is very much similar to Hadoop combiner function. So in Hadoop, we have seen combiner function, right? So it will combine all the what produced result, and then it will give a what one single result. Same thing used to be what done by reduced by key here. Okay, and next to that we have a join function. So this will join two RDD, so which have a key value pair. And next one, the last one we have is, what is that? Coalescent, correct? No, this will reduce us the number of partitions. Okay, so guys, these operations help you to transform raw data into meaningful informations. Okay, so now this is about transformation. Then what about actions, guys? So actions trigger the executions of a Spark job. So let's look at some key examples. The very first one I'm taking here, count function. Guys, count function returns the number of elements. And what is the functionality of collect? See, this brings RDD data to the driver. Okay, so this is only for the small data set, guys, not for larger data sets. So this is useful only for small data sets. And next we have take. So take, and also we are passing n here. So this will fetch us the first n element. And what about top? And we are passing n here. So top returns the top elements by order. And next we have count by value. So as the name indicates, it count occurrences of each value. And next to that we have reduce, and we have fold function. Guys, reduce and fold functions aggregate the data using commutative operations. And we have separate aggregate function also. So this allows different output and input types. And finally, we have for each. Maybe you all know about for each, right? So this applies an operations on each element without returning result. Guys, can you all tell me now? Can you all tell me now? I'm going to ask you one question, guys. So which action would you use to check the first 10 records of an RDD? What is your answer? So which action would you use to check the first 10 records of an RDD? What is the right answers, guys? Okay, top. Okay, so one of your friends are saying collect. Okay, top also given by one of the student. Okay, take or collect. Very good. So what exactly the value of n here? Jyoti, your answer is correct. What is n? I have mentioned value records, right? How many values? 10, right? Then take of 10, collect function with take of 10 subset. Correct now? So this will help you to check the first 10 records of an RDD. Fine. So now we are moving forward and we are discussing about pair RDD. Guys, Spark often works with the data in key value pairs. Okay, this format we are going to use here, guys. So your RDD will always use this pair of key value. Okay, we can call this as pair RDD. So this is usually called as pair RDD. Guys, pair RDD enables operations like group by key, reduce by key, combine by key, and many more, guys. Here we have mentioned many more, right? Okay, and you can apply map value. See, here we have a function. You can apply map value of f to transform only the values and keeping the keys unchanged. So in this case, keys are unchanged. Okay, only you can transform values here. So, and also actions like count by key, collect as map, and lookup key. So these are all commonly used for analytic task, guys. Analytics task. Okay, so look at this important point, guys. I've told you, right? Pair RDD form the foundation for structured data processing in Spark, even before data frames and data sets come into the pictures. So here I've taken one example to explain on that. All of them look at here. So now I'm going to call you as a programmer, guys. So programmers, guys. So now, my dear programmers, let's see some real Spark Shell examples with the CSV file called bank CSV. Guys, initially what we are doing. So we have started with Spark Shell. Correct? No, that is the very first step we have done. And we are loading this data, bank.csv data, by using this statement. So sc.text file. So it is opening CSV file and it is loading this into bank data. So then after performing this, so we perform a simple flat map and filter to extract line containing the words admin. Okay, where we are performing that operation. See, this is giving bank data dot take we have taken here, and array of string. So array we have mentioned all the attributes, and then after that, see, look at here everyone. So we have taken flat map, and also we have taken filter function. Guys, these two functions perform. See, these two functions extract lines containing the word. Which word I'm talking about here? Admin. Understanding my point? So then after performing that, so we have result inside this bank data too. So now we have started what? Counting it. And it is going to show how many records are there. Okay, so here it is returned 11334. So next to that, so we have a map function. So we map each line to a tuple of what we have taken here. So tuple of two things we have taken here. What we have mentioned here. See what was the values we have taken here? Age, job, marital, education, default, balance, housing. These are all the attributes we have taken, right? So now, guys, we map each line to a tuple, education and age. Look at here. So we have taken third column. This is starting with 0, 1, 2, 3, third column. So we have passed third column here, and here we have passed 0. What do you mean by 3 and 0? So 3 is indicating for education and 0 is indicating for age. So for that, we are going to use map of x tends to x dot split, comma operator we have taken, and then third column we have mentioned here. So same thing with the 0. And we are converting it into integer at the end. Understanding my point, guys? So finally, we print each pair. So where we have stored data here. So we have stored data here, right? So we print each pair. See, we have used for each function. See, we are printing each pair to verify here. This demonstrates text processing and filtering in RDD. So this is the output we are going to get at the end. I hope this example is crystal clear to everyone. So is this clear? Is this clear? You're all getting right? You're all understanding, right? This is very simple examples, guys. These are all very simple examples. And also in Labware, we have mentioned all the programs with respect to your Spark. I want you people to execute after completion of this class. Now look at here. We have taken one more example. So in this example, we apply reduce by key. Reduce by key. So why we are applying this reduce by key here? Because we have to sum up ages grouped by education. Okay, so here I mentioned add up all ages by education. That is what exactly I'm trying to do here. So we get something like, what is the answer we are going to get next? Secondary 42,848. This is the value I'm getting now. And tertiary, I'm getting 55,817. And primary, I'm getting 2003. And unknown, I'm getting 1857. Okay, this is the output I'm going to get at the end, guys. Guys, Then we swap key value pairs using, see, for swapping purpose, we are going to use this. See, here I mentioned all these steps, guys. You just look at here. So we swap the key value pair using map, in bracket I have passed underscore dot swap. So by this, we are going to get all these values. Okay. So 42,848 secondary, 5,817 tertiary. See, we have swapped key value pair, so on and so forth. And finally, what we are doing? So we sort them by using sort by key. And we have mentioned number of partitions is equal to 1. So this is used to get a sorted view of the data. See, it is showing in sorted format. And finally, guys, so we can look up specific keys using lookup primary. Okay, so which always returns array buffer. That array buffer is equals to 2003. So this will find the value for the key. So this is the second example. And third example also we have taken here. See, this third example, we are using count by key. Okay, what is the main functionality of count by key? Already I've told you, right? So this count by key returns a Scala map, not an RDD, since it is in action. Okay, so we then convert this map into RDD. So for that, we have to use parallelize function. So by using this parallelize function, I'm converting Scala map to RDD. Understanding? So next we join this with, see, next we are joining this with bank data 4. Correct? No. We join with this bank data 4. You can observe here. Okay. So this is creating a pairs like secondary. So here, see, we have joined the two values. Secondary 1084. And finally, we compute average age per education category by using this statement. So this is used to what? Calculate the average. I hope each and everyone understood. Okay. So what is the result of this, guys? The result of this is secondary 39.52, so on I'm getting here. Tertiary 34. See, it is sum up all the values and it is calculated average. Guys, beautiful example. This beautiful example shows Spark power to combine, join, and aggregate data with just a few lines of code. I think I have shown you MapReduce programming, right? In MapReduce program, we have written code to understand that. But here, not like that. Look at here, guys. It is very easy. So we have to remember only few functions. That's it. So these are the three different examples, guys. I hope till here everything is clear. Is this clear? Shall I get quick confirmation? Shall I get quick confirmation? Guys, after completion of this class, you go and try by yourself. Then you will understand in better way. Okay. Thank you all, guys. Now, guys, look at here, everyone. So I want each and everyone to look at this diagram. So every Spark job creates a directed acyclic graph. So that is called as DAG. Okay, in short form, we are going to call it as DAG. Guys, I'm repeating. See, whatever the job you are going to create by using Spark, that will create DAG of operations. So in that DAG of operations, vertices represents. So we are going to take vertices, right? So vertices represent RDDs and edges represent operations. Clear? Are you all understanding? And this DAG is divided into stages. See, look at here. So this DAG is divided into stages. Stage 0, stage 1. and each stage having multiple tasks that can run in parallel. See, and this is. See, all these things, three things are running parallel. Guys, this DAG helps Spark to overcome the limitations of Hadoop MapReduce. So, which executed each stage independently with heavy disk input output. Here, what it is doing, guys, it is executing parallelly. It is not executing sequentially like your Hadoop MapReduce. Guys, by keeping intermediate data in memory and breaking the job into optimized stages, Spark reduces overhead, and this will achieve fault tolerance through RDD lineage. Understanding my point, guys? So this is about Spark concept, guys. And next, look at here. So next we have done with RDD operation. Okay. Now let's revisit our flow, guys. So we have covered RDD operations thoroughly. Next, we will be discussing standalone applications, how to write, how to configure, and how to execute Spark programs outside the interactive shell. Okay, so the very first slide is saying about core Spark concept. Look at here, everyone. So before going to standalone application, let's recall the core concept of Spark distributed execution model. Guys, Spark is a cluster computing framework where a program runs in parallel across nodes, and this is completely managed by a driver and executor. Understand this. So this is completely managed by the drivers and executors. I hope everyone understood now. Okay. Then look at here, guys. Then what is the driver? What is the driver? Guys, every Spark application starts with a driver program. So, guys, the driver runs the main function. Okay, so this defines distributed data sets and this perform actions. Okay, the driver accesses Spark through Spark context. See, already we have discussed about Spark context, right? So this is the object we are going to use to access driver. Guys, this Spark context object serves as the connections to the cluster. Guys, in this shell, the Spark context is automatically created and available as SC. That is in case of what? Shell concept. Okay, but in case, see here, Spark context is used to build the RDDs in case of what? Shell actually. Understanding? And guys, executors. So executors are worker processors running on cluster nodes that execute a task and store cached data. Okay. Now look at here, guys. So the driver program. Okay. The driver program. See, the driver program contains logic of your Spark application. Remember this. This driver program contains the logic of what, guys? Logic of the Spark application. It creates RDD, defines transformations, actions, and coordinates distributed executions. And without the driver, no task will be scheduled. Remember this. Okay. And one more very, very important point is the driver is equal to your control tower in Spark. Now I have to ask one question to you all, guys. So after understanding this, now tell me, guys, what happens when the driver process terminates? Yes, what is your answer? What happens when the driver process terminates? See, one of the student is asking, what is the usage of a DAG? Can you explain again in Spark, right? So yes, I think so. For this, one of your friend has given right answer. What is the usage of a DAG? Can you please explain again? So for that question, so one of your friend answered. So it is used in creation of pipeline. Correct? No. Guys, usually listen to me carefully. So usually in Spark, okay, so this DAG is represent the execution plan of your Spark job. Okay, so guys, already I've told you, right? So how Spark uses DAGs. So it will take RDD. Okay, it will take DAG construction, stages, task scheduling. So everything it is going to do, guys. The DAG is used for mainly in advanced version, I'm telling you. So it is used for query optimization. See, for example, Spark optimizes the execution plan by rearranging the DAG to minimize the data shuffling, and also it is used to improve the performance. Okay, so even it is going to play the role in fault tolerance also, in lazy evaluations also. Okay, so what I would like to say here is, so DAG is a one of the critical component that is used to enable the efficient, scalable, and fault tolerant processing of large data set. I hope this answer is crystal clear to Ravi. Ravi, is this clear? I think Ravi is asked this question. Correct? No? I don't know what is happening with the system here. Suddenly it is hanging. Okay. Once again, guys. Okay. So I was asked you one question, right? So what happens when the driver process terminates? Yes, many of them has given right answer. The entire Spark application stops, guys, and the executors are released. So that is the answer for the question asked. Okay, now I'm moving forward and I'm discussing about next slide. Guys, standalone applications. Now we move to standalone Spark programs. Guys, you can write these programs in Java or Scala or by using Python. But the API is the same across languages, guys. So in Python, you write a script and execute them using /bin /spark submit command. So you can use this command. So this is used in Python, guys. Okay, guys, this is Spark submit. Okay, so here I've given instructions. This Spark submit automatically sets up dependencies and environmental variables needed to run Spark's Python API. That is one advantage of using this. Okay, so what you have to note down here, guys, the PySpark package must be installed to use Python with the Spark. That you should understand. That point is mentioned at the end. Okay, so now moving forward, see here, to initialize your own Spark application, you have to perform some tasks, guys. The very first one is you have to import Spark libraries. Correct? No? So here you have to import Spark libraries. You can see in the examples. So here in very first line, so we have imported Spark libraries. So once this is done, so we are using a line of what statement here. So for successful installation of your libraries. And next to that, see, we have to create Spark config to configure the application. Guys, this object Spark config is used to configure application name and also master. See here, you can observe spark config.set master, set application name. Master name we have taken as local and application name we have taken as my script. And next to that, so we have to create. So this is second step. So this is third step. So we are creating a, see, we are using Spark context. Guys, we have to create a Spark context to connect to the cluster. See, we have connected to the particular cluster by using this Spark context. Understanding? I think everyone are understanding, right? And after that, so after that, you can use this sc.text file readme or other methods also you can use, guys. Not only this you have to use, you can use other methods also to create a RDD. But here I'm using what exist see first method of your RDD. And after that, we are applying transformations and actions. And finally, so once everything is done, then what you have to do, guys, this is very, very important. So call sc.stop to end the session. This is compulsory. Don't forget to do this, guys. So this is the basic life cycle of the standalone Spark program. I think now you all understood, right? And this is the program I've taken. So here I have left with this last statement. You include this last statement here. Okay. This is the best example to explain standalone application. Okay, guys. Now I'm taking next one. So once your standalone Spark program is ready, so it is a time to execute it. Correct? No? To run it, we use the command spark submit. See, look at the example given here. Look at the example given here. So what we have done, spark submit myscript.py we have mentioned here. Guys, this command automatically configures class paths, dependencies, and connects to the local or cluster mode depending on your setup. Okay, so it is that simple. You can now move from experimenting in Spark Shell to running full-fledged Spark application. Okay, now I have a question to you all, guys. Let me see how many of them are going to give a correct answer to this. So why do we prefer Spark Submit over running a script directly using Python? What is your answer? Why do we prefer Spark Submit over running a script directly using Python? That is my question. So that answer already I've told you, right? What is the correct answer? Guys, the reason for this is Spark Submit handles dependencies, cluster connections, and resource allocations automatically. Correct? No? That is the reason for the particular question. Okay. Now I'm jumping into next topic, guys. Guys, we have done with RDD operations. Okay. So see, we are glancing at what today's agenda once again. So we have covered RDD operations and standalone applications. Now we move to the third and most important section, that is called as cluster architecture. So we'll see how Spark executes jobs in distributed environments, how drivers, executors, and cluster managers interact. Okay, then what is the motivation to this? Guys, until now, so we have been running Spark in local mode on our own machine. But what if your data is so huge that one machine cannot handle it? So then definitely we have to move to cluster, right? So definitely we have to move to cluster. Okay, now here is the beauty, guys. Guys, Spark allows us to run the same application code in cluster mode without any modifications. Is this not beauty, guys? So you simply add more machines and Spark automatically distribute your task. So is that is not that amazing, guys? You can prototype locally, then scale to hundreds of nodes with no code change. That is the beauty of using Spark, guys. And look at here, everyone. Let's understand Spark runtime architecture now. So when you submit a Spark application, see here, you're submitting your Spark application. It involves several components. What and all it is involved? See, guys, it is involved driver. It is involved executors. Okay, it involves cluster managers that orchestrates everything. Correct? No. So this is orchestrate everything. So look at this diagram. So it clearly shows how Spark distribute executions across nodes. See, we have taken from here, this is distributed to node 1, node 2, and also node 3. And on each node, we have executor. And on each node, we have cache memory. And the tasks are distributed here. Okay. So we'll now dissect each of these components and understand their responsibilities one by one. Okay. So what is the first one? Guys, Spark follows master slave architecture. Okay, so this is very, very important. So Spark follows master slave architecture. Guys, the driver acts as a master here. So driver will be always acts as a master and executors acts as a slave. Okay, so here we have two slaves, right? Worker node, or we can call it as worker nodes. So both run as separate JVM process. Remember this. So together they form one Spark application, but both are running as a separate JVM machine. Guys, the driver program communicates with the executor by using this cluster manager. So this is used to launch and monitor them. So launch and monitor. Both the job has to be done by this cluster manager. Guys, listen to me, everyone. Spark supports several cluster managers, not only one, guys. So its own standalone manager, Hadoop Yarn, Apache Meos. So these are all the best examples. So whether you are using Hadoop or not, so Spark can interact easily with any of these environments. Okay, so now let us discuss about driver, guys. So already I've told you, right? So the driver is the brain of Spark application. So it runs in its own Java process and executes the main method of your code. Guys, it is responsible for creating RDD, okay, applying transformations and actions, and coordinating all the tasks. So when the driver finishes execution, the Spark applications also terminates. So once everything is done, means Spark application will also terminate. Now my question to each and everyone is, guys, if a driver fails mid execution, what happens? What is your answer? Okay, this is a beautiful question, right? What happens, guys? The application stops, right? The complete application stops, right? Because executors depends on the driver instructions. But here driver only terminated. Driver only failed to what execute. Then how it is going to continue, guys? So that's why driver are typically deployed on reliable nodes. I hope this is clear to everyone. Now, see, now look at here, guys. Look at here carefully. Okay, when the driver runs, it first converts your logical code. Okay, this is very, very first point. The meaning of this is all those transformations and actions converted into a DAG. Okay, everything will be what converted into DAG, directed acyclic graph. Then Spark scheduler. So then we have what? The concept of Spark scheduler. The Spark scheduler breaks the DAG into number of stages. So this will be what broken down into number of stages. You can see in the diagram. Okay, and each containing multiple tasks. Each stage will be containing multiple tasks here. And tasks are the smallest unit of work that executors perform. So what you have to understand here is, so when you submit a Spark job, the driver does not execute the transformations directly. So it builds a plan and delegates tasks to executors. That's all. Very simple job, guys. Okay. Then what about scheduling, task scheduling, scheduling task? Guys, once the driver generates the execution plan, it schedules the task on executors. And executors register themselves with the driver. So the driver knows exactly where to send each task. So before that, we need registration, guys. Okay, registration is very, very important. When a task complete, okay, when a task complete, its result or cached data are reported back to the driver. Simple, no? Very simple concept, right? Okay, the driver then uses this cache data to schedule future tasks efficiently. Guys, in short term, the driver coordinates what to execute and where to execute it. That's it. Very simple. Okay, very simple thing I'm telling you guys. Now look at here, everyone. Driver program translation into task. Guys, we go deeper into this Spark scheduling system. Look at here, everyone. The Spark internally uses several components. What are those components? I have divided that component into 4 types. So this is the very first component. The very first component is called as DAG scheduler. Guys, this DAG scheduler already I've told you, right? So this is used to break a job into stages and then submit them. And what about the second one? Task scheduler. Guys, task scheduler actually sends task to the cluster and monitors the execution. See, sending tasks to this cluster, running them and retrying if there are failures and mitigating straggles actually. So this is monitors the execution. And one more we have, guys, that is the third type. This is the second one and this is the third one. That is called a scheduler backend. Guys, this scheduler backend interfaces with the underlying cluster manager. What are those underlying cluster managers? Either it is going to use Mesos, Yarn, or standalone or local. And finally, we have the fourth one. The fourth one is called as block manager. Guys, what is the job of block manager? Guys, block manager handles data storage. Not only data storage, guys, retrieving options also. And caching across executors. See, all these jobs done by block manager. Guys, together, these ensure efficient task execution, retrieve on failure, and fault tolerance. So this is about driver, guys. So now I'm moving forward and I'm explaining you about executors. Okay, so already I've told you, right, what is executors? So executors are the workers in the Spark clusters. Okay, and executors are responsible for running individual tasks assigned by the driver. And they also provide in-memory storage for RDD that are cached by user program. Guys, very, very important point is, even if executor fails, Spark can continue running because tasks can be rescheduled elsewhere. Then what are the roles of executor? Already I mentioned, right? Run the task and return the result to the driver and provide in-memory storage. These two responsibilities already I've told you. Correct? No. So guys, executor is equal to what, guys? So executors is equal to task executors plus data cache holders. data cache holders. Correct? No? Okay. Then what about cluster manager? One more component. I'm talking about the third component, that is cluster manager. Guys, the cluster manager is nothing but an orchestrator or monitor. What is the role of this, guys? Guys, its role is to allocate resources and launch executors across the cluster. And one more very important point is, guys, it is a pluggable component. The meaning of this is Spark can work with different managers like Yarn, Mesos, or its built-in standalone manager, guys. That's why it is called as pluggable component. And you submit your application using Spark Submit. And the cluster manager takes care of everything, guys. Only the thing is you have to type the command Spark Submit. That's it. Remaining all will be what taken care by Spark cluster manager. So whether it is resource allocation or monitoring, scaling, cleanup, so on and so forth, all the task has to be what taken care by the cluster manager. No need to worry. Okay. Then what is application execution? Guys, now see how Spark applications execute in a cluster. Look at the diagram, guys. I have taken very beautiful diagram. So from this Quora. Okay. The very first step is the user. See, look at here. So here we have a user. So user submits the job using Spark Submit. Correct? No? He will use Spark Submit to submit the job. Then who is going to play the next role, guys? The driver, right? So next driver is going to play a role here. Guys, the driver program starts and request resources from the cluster manager. Okay. That is the second step. Third step is the cluster manager launches the executors. Correct? No? And after that, see, after launching executors, the driver sends a task to the executors. And what is the job of executors now? See, guys, executors process the data and return the result. See, it is processing. See, submission is done here. Next, it is processing and it is submitting result back to the driver. Okay. So when done, the driver terminates, all the executors are stopped. Guys, it is simple, it elegant. Correct? No? So complete life cycle managed through this Spark Submit. Okay. And I have one more slide here. So this is giving a detailed information. So more detailed view I'm giving you here in the 7 steps. So guys, when Spark Submit is run, it invokes your application main method. Correct? No? That already I've told you. So the driver then contacts the cluster manager to get executors. So executors are launched on worker nodes. Executors are launched on worker nodes and task starts executing in parallel. Okay. So as transformations are computed, so intermediate result may be cached here. Once the driver finishes st.stop, sc.stop, okay, the executors are released. That's all, guys. Very simple. Or you can call this function spark.stop, or in short form sc.stop also you can use. Okay, guys, that's how Spark achieves full lifecycle management from job submission to the resource cleanup. Okay, so now I'm continuing with one more diagram. You just look at here. This is the flow diagram. So flow diagram of your application execution. Okay, or we can call it as application execution flow only. So what it is summarizing, guys? So it summarizes everything we have discussed visually. Correct? No? So what is happening here, guys? The very first thing is job submission. So here we are performing job submission. And next, driver utilizations. Okay, driver utilizations. And next to that, we have executors allocations. Executors allocations is also happening here. And next to that, we have a task scheduler or task distributions and result collection. So once results is collected, so it will clean up everything. Remember guys, all this is automatic once you use Spark Submit. I'm repeating. So you just need to focus on your data processing logic. That's all. Okay, so that is about Spark components, guys. So now, before moving ahead, so let's make sure we understand cluster concepts like nodes, cores, executors, and deployment modes. Guys, you can observe here, each node can host multiple executors, and each executor can run multiple tasks. So multiple tasks, how guys? Concurrently, depending on the number of cores assigned. And these parameters are memories, cores, number of executors, guys, are all configurable during job submission. Correct, no? The same thing is given in this entire table, guys. You just go through this. So finally, to launch applications on a cluster, we use Spark Submit. That already I've told you, right? Okay, that command we are going to use. Guys, this command provides a uniform interface to submit applications regardless of the cluster manager. So it is not going to see whether we have submitted by using standalone applications manager or yarn manager, mesos manager, or Kubernetes. Okay, so if your application has dependencies, you will bundle them using assembly jar. Okay, or we can call it as Uber jar. So by using this, we have to bundle all. Guys, in Python, dependencies can be passed using, what is the command we are going to use, guys? --py--files. So this is the flag we are going to use in Python. So for multiple files, zip them into one archive for easier distribution. Okay, that point I have mentioned here. Now I have a question to you all, guys. So let me see how many of them are going to give a correct answer to this. So why do you think Spark requires packaging dependencies? Why do you think, guys, Spark requires packaging dependencies? Because executors running on remote machines, correct? No. Am I right or wrong? See, executors running on remote machine that need access to the same code and libraries. I think everyone are understanding. Okay. Now launching applications. So launching applications with Spark Submit. Guys, once your application is packaged, you launch it using this command, guys. /bin/spark submit script. So this is the entire script we are going to use there. So this script set up the class path. So that includes Spark dependencies and supports all the deploy modes and cluster manager. So it is the standard way, guys. So this is one of the standard way to run production level Spark applications. This is one thing. And the next one, see, look at here, everyone. See, these are all the common options we are going to use, right? See, these are all the important options used at the time of Spark Submit. Okay, at the time of what? Spark Submit. What are those options? The very first option is called as --class. Guys, this is the entry point for the applications. See, example I've taken here, arg.apache.spark examples.spark.py. Okay, this is for the entry point for the application. And next to that, we have --master. So --master means we have to take the URL of the cluster. So this is how we are going to mention URL of the cluster. So with port number. And next to that, we have --deploy mode. So here, whether to deploy driver locally. So driver locally is nothing but client, right? Or on the cluster. That is the deployment mode. And next we have hyphen configuration. So this is for passing configuration properties. And next we have application jar. So this is required to this is used to what? Give a path to your jar file or Python file. And next we have application argument. So this is any arguments passed to the main function is called as application arguments. So remember this, guys, all files path must be visible to every node in the cluster, either through HDFS or shared by file system. That you should understand. And next to this, we have some code here. Guys, this complete slide shows the process of launching applications on a standalone cluster using Spark Submit. Okay, so the workflow remains the same here. Okay, the workflow remains the same. The only difference lies in the master. Okay, only difference lies in the master. That's it, guys. Correct, no? See, in master, see here we have taken local 8. Here we have taken some address. Here we have taken same address. Okay, so master argument is different here. So where you specify the master node URL of your standalone cluster. Guys, this allows the same program to run on any setup by just changing the configuration. So better all of you go through this. This is very, very important one. You can run it anywhere, guys. With any configuration, you can run this. Okay, and next one. So what we are doing here, we are launching applications with this Spark Submit again. So here we see examples for yarn cluster. Okay, to submit a Spark job on yarn. See, previously I have told you, right? So either it will use standalone manager, yarn manager, Mesos. But here, particularly, you have to submit it on yarn means, then you have to use this command. So what you have to mention here, look at here, guys, everyone. Spark submit. Spark submit. See, in master you have to mention yarn. Very simple. Okay. And then you can mention the file name. What is the file name? So file name depends on you, guys. Or else simply you can use, let me write here, Spark submit master, and then mention yarn, and then write your application name. Suppose you are writing that in Python program. So this is the command you are going to use here. Okay. So depending on your mode, you can specify deploy mode. That is depends on you. Or you can use cluster mode. Okay. So we'll discuss what these modes mean shortly, guys. So simple modification in command, but the logic remains unchanged. Correct? No. And next slide, look at here. See, this one covers the submission to Mesos and Kubernetes clusters. So nowadays in companies, the maximum people are using Kubernetes, right? So see, look at the master URL. So again, the master URL is differing. See, master URL we have taken as Mesos. Master URL we have taken as Kubernetes. Correct? No? So you have to mention, see, or else what you can do, guys, suppose you are using it in master means take Spark submit master, and what you have to mention? You have to mention Mesos / node. You have to mention here Mesos node Mesos node : you have to use the port number as 5050, and next to that you have to mention file name myapplication.py. So this you have to use for Mesos. Or you can using the same thing for Kubernetes means only you have to change K8s. That's it, Kubernetes. And so in the place of this, you have to mention API server name. And port number would be always 443 in case of Kubernetes. And remaining all my application PY, everything is same. So Spark is flexible, guys. It supports multiple environment seamlessly. This is beauty, right? And look at here, finally. So for Python programs, you can use what you can use here, guys, for Python program. Already I've told you, right? Slash hyphen py files option you can use. Okay, this is used to distribute .py file or .zip file or .egg file. So along with your main Python script, guys, this ensures executors have all required models to run your program. So how we are going to use this? Same methodology you are going to use here, guys. So either you can use master Spark like this, or you can use separately this py files space your zip file name you have to mention there, and then main.py. And these small flags make Spark highly customizable for developers. Correct? No? So now look at here, guys, everyone. So this is showing what it is showing, guys, master URLs. See, these are all master URLs we have mentioned here. So whatever we have used in the previous slide, I have put everything in a single slide here. Okay. And next to this, so we are talking about loading configurations from a file. Now, guys, look at this slide. Spark also allows configurations through files. Is it not beauty, guys? The default file is config spark-defaults.config. So you can predefine properties like. So you can predefine your properties like, let me write here. So you can write spark.master is equal to spark : and then you can mention localhost : 7077. Okay. And you can mention spark executor dot memory is equal to 4 GB. So this is left to you, guys. Then you don't need to specify them in Spark submit. Not required. Okay. Then what is present order here is? What are the precedent order here is? Guys, the very first one is Spark config. That we are going to use in code. So this we are going to use in code. And next we have what? Command line flags. And finally, so we are going to take default files. Guys, if confused about active configurations, run Spark submit with --verbose to see the details. Okay, so once you are running this, so along with your Spark submit, you will get all the details of your active configurations. Okay, that is clearly mentioned here. Okay, next slide, scheduling Spark applications. Guys, when multiple users share a cluster, scheduling becomes very, very important. If two users submit a heavy job simultaneously, the cluster manager decides how to allocate resources. Guys, Spark depends on the underlying cluster manager. For what? For fair resource sharing. Depending on the contention, an application may get more or fewer executors. So Spark's flexibility also depends on how well the cluster manager schedules workload. Correct, no? So look at here. We have taken standalone cluster manager informations here. So this slide completely explaining on Spark own built-in standalone cluster manager. What it is containing, guys? So it is containing two things. What are the two things? The very first one is master node, and the second one is worker node, multiple workers. Okay, and each worker with defined memory and also cores. Understanding my point, guys? See, when you submit an application, okay, when you submit an application, you specify how much memory its executor will use. Okay, and how many cores it should use. Both you have to mention. Number of cores and memory, both. Okay, to submit, you see, so what you have to do, guys, to submit, You have to type hyphen master and then mention Spark :/ what is the node you have to take here? You have to take master node :7077. So you can also access the web UI, guys. So you can also access the web UI at the same cluster URL to monitor the job. Okay, so that we have mentioned here. Okay, you're all getting now. And look at here, guys, standalone cluster manager. So this is called as deployment modes, guys. My dear students, let's now discuss the two dependent modes in the standalone cluster manager. What are those, guys? The very first one is called as client mode, that by default it will take, and second one is called as cluster mode. See, under client mode, so we have taken 3 points. So what is the very first point, guys? The very first point is saying the driver programs runs on the same machine where you execute Spark submit. And the second point is saying you can see your logs and outputs directly on your terminal. And third point is saying this machine must have fast connectivity to the cluster worker. Okay, so this is for the client mode. And then what about cluster mode, guys? So even cluster mode is containing 3 points. So here, the very first point is saying the driver is launched inside the cluster itself. Okay, so this is this as one more process on a worker node. So once you submit, you can close your laptop and still the job keeps running. Okay, is not that nice, guys? Okay, so fire and forget mode. It is like a what? Fire and forget mode. Correct now? So logs can later be seen through the cluster manager's web UI. By using this, you can see all the log files. Okay, and next look at here. So next I'm talking about resource configurations. Guys, look at these two important settings. So and also these two important settings are very, very important. Okay, so they control how much resources your application Spark uses. The very first one is called as executors memory and second one is total executor cores. Already I've told you, right? What is executor memory means? The amount of memory each executor can claim, that is called as executor memory. Okay, so that is configured by using this executor memory in Spark submit. Okay, so by default value, it would be always equals to 1 GB, guys. And what about total cores? Total executor cores, guys. The CPU cores used across all executors for the application. Total number of CPU cores used across all executors for the particular application is called as total number of cores here. And this is set by using this total executor cores with Spark submit. So if you don't limit this, so Spark will launch executors on every available worker. So that's why we have to restrict this, guys. We have to limit this. So always tune these values to avoid overloading the cluster. Okay, now I can ask you one question, guys. So my question is, what could happen if we assign too many cores to a single Spark application? What is your answer? Guys, the question is very simple, right? What could happen if we assign too many cores to a single Spark application? So it may hog the entire cluster and starve other applications. So exactly that is called as, so what is exactly required here? Balance is the key here. Okay, that is what I would like to say now. And the next one is I'm talking about high availability. Maybe you all know about high availability, right? So even clusters can fail. So high availability is essential. Guys, the standalone cluster can survive worker failures gracefully. So workers reconnect automatically. But if the master node fails, we need a backup mechanism, guys. Guys, can anyone tell me what backup mechanism we are going to use? Guys, we are going to use Zookeeper. Okay, so we are going to use Zookeeper to maintain the multiple masters in a standby mode. So if one fails, so another task means another what node will takes over without manual intervention. See guys, this ensures your Spark cluster keeps running 24/7 with no downtime. With no downtime. Okay. So I think till here everything is clear. Now I'm talking about Hadoop yarn. So now moving to another cluster manager that is called as Hadoop yarn. Yet another resource negotiator. Guys, already I've told you, right? So yarn was introduced in Hadoop 2.0 and it is often installed on the same nodes as HDFS. So if your data resides in HDFS, running Spark on yarn makes perfect sense. So data locality and also speed is perfect here, guys. So you just need to set the environment variable. See, these are the environmental variable you have to set, guys. So what are the two things you have to set here? Hadoop config directory to the directory containing inside what? yarn-site.xml. And then submit your job as Spark submit master yarn my application. Okay. So Spark on yarn support two deployment mode, guys. What are the two deployment mode it is going to support? The one it is going to support client and another one it is going to support cluster. Guys, in client mode, the driver runs on the machine where you submit the application. But in case of cluster mode, the driver runs inside the yarn container on the cluster. And very, very important thing is the choice depends on your use, guys. Choice depends on your use case. Okay. So for deployment and debugging, so use whatever the mode you require, guys. Okay. Are you all understanding? So, and one more thing is Zookeeper can again be used for multi-master failover supports. So essentially Mesos treats Spark as one of its framework. So offering fine-grained resources sharing. So that's why I'm taking Mesos here, guys. So I'm taking Mesos also here. Okay, guys, in Mesos, Spark can run in two modes. So one is called as what, guys? Course A grind. This already we have discussed in cost concept and fine grained. So here, how the course A grind mode works, guys? Correct. Now that is the question, right? So let me explain you, guys. Let me explain you. So that is given in next slide. Yes, here it is mentioned both. So in coarse grind and also, and one more is what? Fine grained. So both they have mentioned here. Guys, each Spark executors runs as a single Mesos task here. And executors are allowed upfront based on settings like Spark executor memory, Spark executor course, and one more is Spark course.max. Here we have mentioned. Okay, and executors remains alive for the entire duration of the job. The main advantage of this is lower startup overhead. But we have a drawback with respect to this, guys. The drawback is resources remain reserved even when idle. Okay, so I can ask you one question. Okay, so in which scenario would you prefer this mode, guys? When jobs are long running and steady, so we can use this. Okay, now And look at here. So Apache Mesos we have given with scheduling mode. Guys, in fine-grained mode, okay, so in fine-grained mode, each Spark task runs as a separate Mesos task. Okay, that means resources are shared more dynamically. The meaning of this is multiple applications can share cores on the same node. However, guys, so this mode has higher overhead since tasks are launched and also terminated frequently. So it is unsuitable for low latency requirement like interactive queries. Hence, Spark has deprecated fine-grained mode in modern versions. So remember that, guys, fine-grained is equal to what? Flexibility, but less performance. Okay, then what about deployment mode? Guys, similarly to Yarn and standalone, Mesos also offer two deployment mode. One is client mode, another one is cluster mode. So client mode means what, guys? So driver runs on the submission machine. Correct? No. So in case of cluster, so drivers runs inside the Mesos cluster. Very simple. So whichever cluster manager you choose, guys, Spark retain the same flexible deployment architecture. That I'm telling you many times. Now, which cluster manager to use? This is the big question, right? My dear programmers, a very practical question. Which cluster manager should you use? So here is a simple guideline. I'm not going to tell you, so this is better, this is not good. So I'm going to give you few guidelines, guys. You have to follow all these guidelines. Guys, if you are deploying Spark from scratch, so start with standard Spark standard standalone cluster. So this is easy to set up and easy to maintain, guys. So that's why I'm suggesting you this for easy deployment or scratch deployment. And second one, if you already have Hadoop and Yarn, run Spark on Yarn machine for seamless integrations with the HDFS, guys. That is my second suggestion, our second guideline. And third one, if you need fine-grained resource sharing or to run alongside other framework, so then you go with Mesos. These are the three guidelines I'm giving you. In all cases, try to co-locate Spark and HDFS nodes for data locality and also speed. So even my suggestion is you go with the second methodology. Okay, so I always expect you people to go with Yarn. Okay, and yes, guys, so this will leverage existing Hadoop infrastructure. That's why I'm telling you, guys. And what is given at the end? So this is the summary, guys. So till now we explored RDD operations and understood how they enable data analysis, and we learned to create a standalone application using Spark context. We saw how Spark moves seamlessly from local mode to cluster mode without code changes. And we studied the architectures of drivers, executors, and cluster managers. And finally, we compared standalone, Yarn, and Mesos managers and understood their deployment modes. Okay, so next we have Spark session part 3, guys. That we will discuss in the next coming class. So that's all, guys. That's all about today's session. So if you have any question on this, you can ask me. So do you have any questions? Guys, actually in next session in Spark part 3, so we will dive into data frames, data sets, and also Spark SQL. Okay, we will see how structured data processing builds on top of RDD foundations we have learned today. And please go through the official Spark document and practice some RDD examples before coming to the next class, guys. That is my sincere request. And try executing small programs in both local and also cluster machines. Okay. And also I have given few system design exercises. So before we close, so let's recall our system design exercise from the session 12. So that I have mentioned, no? Yeah, better you go with that, guys. I have given all the solutions. I don't want to explain it again. Okay. So now that's all about today's session. So let me conclude. Yeah, Ravi is asking some question. Yes, Ravi. What is your question? Is it on today's concept? I think we have covered a lot today, right? From setting up Spark to understanding its runtime and deployment architecture. So I want you people to review the commands, especially Spark submit, and try creating a small standalone application that reads CSV file and computes some aggregations using RDD. I hope the concepts of drivers, executors, and cluster managers are clear now. Is this clear? Why I'm not getting any messages? Is there any delay in sending messages? So before we end, so can anyone summarize why Spark DAG based execution is better than Hadoop MapReduce? So do you have any problem with message typing, guys? I'll do one thing. I will enable mics for you people. Yes. You can unmute your mic and answer.
Yes, sir.
Yes.
Ravi this side.
Yeah, Ravi.
Looks like
Do you
your
have any
chat
questions?
is looks like your chat is hanged. There are lots of messages there. Okay.
I don't know
Anyway,
why the chat box is not running. It is
okay.
stuck
Just
somewhere.
no problem, sir. So, sir,
Oh,
it's
now I'm
my
getting all the messages. Look at here.
yeah. Okay, my query was related to the assignment. There were some data sets are being referred, right, in the guideline to pull out that data set for Facebook or Instagram something.
Okay.
So we need your help to understand that data set actually. If you can, I mean, I don't know if your availability, if you today or post this session or tomorrow, is it possible if you can help us to understand that data set so that we can? I'm actually unable to correlate and the data with respect to the assignment. That's why I have some confusion on that.
So what is your problem, bank?
30, I have a group 34.
Group 34 means what is the problem bank number? Problem number 34, right?
Yes.
Okay. Can you tell me briefly what is your problem statement is?
The data set, I'm trying to understand the data set, sir. There are nodes, edges, there are so many things, so much data inside there. So just need your help to understand that.
Okay. Do you want me to connect separately tomorrow?
Yes, sir, because I mean, I believe everyone has a different like assignment. So I think
Yeah, we
maybe
can connect, Ravi. So for
can
that,
connect.
you send me Google Team message. So once I'm free, I will join. Either we can join tomorrow or day after tomorrow.
Okay. What time, sir? I should send you.
You ping me, okay? So once I'm free, I will be respond to you immediately.
Just like earlier we connected like 7
Yeah.
or something.
Yes, Ravi.
Okay. And second query is the labs. Is it all? I mean, I believe you remember that the imaging issue that they had. Is it all?
Now it is perfect, Ravi. Just now we have checked. Actually, I and Jaswant both have checked. So it is working perfectly.
Okay.
See,
I'll.
Ravi, what I would like to say is, so don't
Mhm.
depend on that particular lab. See, I am
Okay.
asking you people to use that lab, okay? But if it is
Mm.
not available, don't delay your assignments. You have
Mm.
AWS access, you create your own instances there and start working on that.
Okay.
Otherwise, you can use GCP also.
I
Okay, that
can. I
Google,
have my Azure account. Can I use that?
yeah. So there you can access and you can complete your assignments. But
Okay.
see why I'm telling you this. So
Mm.
once we have what provided very good lab to you people, why can't you use? Okay, you can use. Actually, I have checked today also. It is working
Mm.
perfectly.
Okay. We'll test it again. I can still have issue. We'll
And
let's set
one
up.
more thing. See, let me show you. Let me share you one thing, guys. So I think my screen is visible to everyone, right?
Yes.
Yeah. So these are the three configurations you have to do, guys. So the very first one. So let me write here. Better you take the snapshot of this. Where is the pen? Yeah. See, this is for Hadoop master. Okay, this is for Hadoop master. You know, right, how to get the IP address. So you take the IP address and then you set like this. And then look at here, guys. So for Spark also at the beginning only you set all the IPs. So we have interchange, that's it. So in see Spark we have installed on slave node 1. So your master is slave node 1. Only the thing is you have to interchange your master and worker place here. And Kafka also same, guys. You look at here. So we have interchange. That's it. So at the beginning, you do all these configurations and you paste it on /etc and host and then start working on that. So these things you have to do in all three nodes. Okay, these changes you have to do in all three nodes and then start working on that. So it will work automatically. Clear? Is this clear? Why I'm not getting any responses? Yes, Jyoti, you have raised your hand.
Yes, sir. The same issue is with my lab sessions. Actually, I already discussed with you. Actually, you told me to contact Sandeep, and so I discussed with Sandeep. Actually, my lab sessions are exhausted. So by mistake, I'm forgot
Your lab
to
sessions are
share.
exhausted, huh?
Yeah, yeah. So I discussed with Sandeep. Actually, he suggested me to drop your mail.
No,
So
what about your teammates? Even their time is exhausted. Jyoti,
no, sir. Actually,
you
it's
have four
with
in a
me
group, right?
only. Yeah, yeah, yeah.
You have four in a group, right? See, for each we have
Ye-
given 20 hours of time.
Mm-hmm.
So totally it is 80 hours. So as a
So
group
is
work,
there any
you can.
Yeah, so is there sir, any other alternative way so that I can do practice? Because I'm unable to do.
Yeah, for that we have to send a what? Raise a ticket with Santosh. Once he is not responding means what we can do, Jyoti. So even you people are continuously sending messages. I am also sending mails to him. So tomorrow I will once talk to him. So with
Yeah,
the what same.
even I discussed with Santosh, so he suggested me to drop your mail. So he is looking for your consent. So I already dropped your mail yesterday.
Okay, then I will give my
In,
consent. Okay,
yeah, sure. Thank you, Lou. Thanks.
for extension I give my consent.
Sure, sir. Thank you.
Okay, Jyoti. Yes, Ajit. Ajit, you can talk to me.
Are we going to have any practical session for this Spark, whatever the learn in theory?
No, actually, in labware we have given all the what manual, right? So with the
Uh,
steps we have given manual. Correct? No.
basic, yeah, yeah. Basically, I just wanted to understand how to do the setups to run all those commands.
No need
Like,
to do any setups, Ajit. Everything is ready. Only the thing is you have to start with the starting command. I've told you na Spark hyphen shell you have to use
yeah,
for this, and otherwise you can use PySpark directly. So
okay.
inside setting, environmental setting, everything we have done. That is not required for you people.
No, no need to install any software.
No need
Everything
to
is there.
install anything. Everything is ready.
Okay, okay,
See, suppose you people are installing by your own means, then everything is required.
okay.
Clear, Ajit?
Yeah, yeah. Thank you.
Yes, Tanya.
So, sir, in case we are not getting instances available and labs are slow, can we use alternative and so that assignment is not stuck?
That I have told you already, right? Many time I've told you. No need to stuck your assignments. You use another alternatives. Not an issue.
Okay, sir.
But you have to complete assignments on time. That's it. Yes, Ravi. You have raised your hand again.
Yeah, sorry, one more thing. I'm trying to find out this content online. I'm just following that the Spark topics are given in handouts. Is there any reference book you can refer to? It will be very straightforward. Otherwise, it will be like every topic you're finding out on the internet.
You're
Just to
looking
follow
for
up.
internet. You're looking for what?
Uh,
Reference.
any reference book and all something for
Yeah, you
Spark?
go to website. Actually, you go to Spark website. So there you have a documentation. See each and every commands, each and every steps they have given clearly. So that is the best resource.
Architecture and all everything.
Everything is there. Otherwise, see, you want brief information on that means you go to that Spark website. Otherwise, you need only important things means. So I will suggest one website, that is Cloud2Go. Okay, you click on this website. So here you have all the steps actually. So this is one website. So along with project, you have all.
Okay.
Okay. So you type in Google Cloud2Go Spark. See, you have a what tutorial here, architecture, everything is there here. See, look at here. And Spark SQL, Spark R, with command they have given.
Okay.
Okay, this is the best one. Otherwise, yes, my suggestion is always refer Spark website. So Spark document. You mentioned Spark document, Spark, sorry. So this is the best documentation actually. You have all the information in this website. See, look at here, step by step, whatever I have explained, everything is there in this website only. This is also best resource. See, throughout my class, I've told you the same thing, right? So from where textbook also I've told, and also this web link also I've told. Is this clear, Ravi Kumar? Sir, are all tools installed in the labs like Flume and Scoopy? Everything is installed. So let me list you. So what and all softwares we have installed? Guys, we have installed HDFS, Hive, Pig, MapReduce, HBase, MongoDB, Cassandra, Scoop, Flume, Oozy, Zookeeper, Neo4j, Spark, Spark ML, Kafka, Spark SQL, Mahout, and also Airflow. See, all these tools we have installed on that particular image. Samanvita, is this clear? Actually, I have not checked with this Flume. So, but Scoop is installed. Okay, for Scoop, so we have installed SQL also. Clear? Yes, sir, all 16 session will come in comprehensive. Yes, Tanya. Actually, Tanya, what I did is I have taken percentage. Wait a minute. Let me tell you this to you all. 40 into 0.40. Yeah. 16 is to 24 marks, guys. So 16 marks from pre-midsem and 24 marks from post-midsem. So 40 is to 60 ratio I've taken. Okay. So somebody asked this question. Yeah, Tanya. $16 marks from pre-midsem and 24 marks from post-midterm. Okay. So anything else, guys? And today I'm going to upload that PPT. So PPT, see, this is since it is open book exam, you have to carry PPTs, right? Material, right? So that material I'm going to post in Taxila portal today, guys. You can download it and you can take a printout of that and you can carry it to your examination. So do we need to carry printouts of all PPTs? No need to carry any printouts. So I'm going to give you PPT, guys. So I'm going to give you the ready PPT with logo. Okay. So I will post you today. You have to take the printout of that. Tanya, regarding this, you have to ask examination center. So whether they are going to allow textbooks or not, I don't know about that. Handwritten notes are not allowed. Okay. So anything else, guys? And thanks, guys. Actually, I was not getting messages here on my chat box, but I've seen many of them answered for the questions. Thank you, guys. So thank you for your help, actually, in middle. Thank you, guys. Actually, we have left with 2 more sessions, 15 session and 16 sessions. So after that, so next week only, see, after completion of 16th session, you have examinations. So start preparing for your examinations now only, guys. Okay, the pattern is same, guys. As see, first you have seen my midterm question paper, right? The same pattern I'm going to use in comprehensive also. First 4 questions, true or false, and then it is a mixture of numericals and scenarios, case studies. Okay. Yes, that's all my end, guys. So if you have any doubt, you can text me in discussion forum. Otherwise, you can send direct message to my Microsoft Teams. So if I am available, definitely immediately I'm going to answer. Otherwise, so you can send your mails to Kamlendra sir. So he is also helping you people to complete anything. Okay, that's all from my end, guys. So if you have anything else, you can ask me. Otherwise, we can wind up the session. Thank you all for your patience listening at the evening, guys. Thank you all.